Redox education. Let us continue with the Daniell cell. We have already seen from here what takes place in the Daniell cell during such a reaction in the Daniell cell. And we say that in the zinc half cell, zinc is more electropositive than copper, meaning that zinc is more reactive and therefore can easily lose electrons the way metals do. So we say that the zinc atoms of the zinc rod loses electrons more readily to form zinc ions in solution, and this is the reaction equation. And also we saw that in the copper half cell, these zinc atoms, the electrons got from the zinc atoms do move through the connecting wire and then reaches the copper rod. As the electrons flow, current flows as a consequence or in effect. And then the electrical energy generated will be actually detected by the voltmeter, which then shows a deflection in the pointer. So as the pointer deflects away from zero, it means that electrical energy has been generated. So those electrons, on reaching the surface of the copper rod, they are gained by the cation in the electrolyte. The electrolyte we are using is copper 2 sulfate solution, and the cation in it is copper 2 ions. So the copper 2 ions of the copper 2 sulfate solution gains the electrons to form copper metal, as we have seen from here. So this is the equation for the reaction in the copper half cell. And I want us to remember, we said that the zinc rod, in this case, is what we call the anode, and then the copper rod is what we call the cathode. But still, the zinc rod is our negative electrode. It has a negative sign because that's where electrons are repelled, produced and then repelled towards the copper rod. So the copper rod becomes our positive or positively charged electrode in this case, but it has got the name cathode because of the reaction that takes place, that is electron gain or the reduction of the copper 2 ions in the copper 2 sulfate solution. Then in this case we saw the equation for the overall cell reaction. So the equation for the reaction is all about adding what we call the reactants together. So zinc plus copper 2 ions plus 2 electrons produces, and the products also we add together on the product side, zinc ions plus 2 electrons plus copper metal. So the 2 electrons on the reactant side and the product sides do chop because they are spectator chemical species on the two sides of the equation. And what we remain with is this one here. Now, let us look at what we call the cell convention for the electrochemical cell. The cell convention, which sometimes we call the cell notation for the electrochemical cell. So in the cell convention, when we are writing it, we shall be representing, or we shall be showing what has taken place in each half cell, starting with what took place first. So we can see that zinc is more reactive than copper. So zinc loses electrons or behaves like a metal faster than copper in this case. So in this case, zinc is more reactive or more electropositive than copper. So the first reaction is the loss of electrons by the zinc atoms to form zinc ion in solution. So we have zinc, it is represented this way, zinc, which is a solid, in this case the zinc atoms, we use a short slanted bar, produces zinc ion in the aqueous state. So this is what takes place in the zinc half cell, and it is what takes place first. Then we shall use two longer bars which are slanted, and this one stands for the porous partition or porous wall or the porous pot, or we can also use it to represent the salt bridge which connects the two half cells together, or the two solutions in the two half cells together. So on the other side, what takes place next or afterwards is the gain of electrons by the copper 2 ions to form copper metal. So in this case, we have got copper 2 ions in the aqueous state, and then a shorter bar here. It produces copper metal in the solid state. So we can see for each of the chemical species that you're going to write here, make sure that you don't omit the state symbol. So if you leave out the state symbol, then it will become very difficult to understand. And remember here that this side we have the anode, and this side we have the cathode. But as for an electrochemical cell, the anode is the negative electrode, and then the cathode is the positive electrode. Please don't, in this case, to contradict it with what we call the electrolysis cell. This is an electrochemical cell where we don't have the source of direct current. The source of the current itself is the reaction that takes place. So don't forget that at the anode, or on this side of your cell conventional cell notation, we have the loss of electrons. So here we have electron loss, or what we call oxidation. So the metal which is used as the anode, or the negative electrode, or negatively charged electrode in this case, the atoms of such a metal undergo oxidation or electron loss to form the ion of that particular metal. Meanwhile, at the cathode, which is made up of the metal which is lower in the reactivity series, there will be electron gain, or what we call reduction. And what is reduced is the positive ion or the cation of the electrolyte. That's why here we are using copper 2 sulfate solution, and in that copper 2 sulfate solution, the main cation is the copper 2 ion, which then gain electrons or gets reduced to form copper metal. Now, another thing that you should not forget is that we may be asked to name the electrolyte used in this case in each case. So the electrolyte we use must be a solution of a soluble salt of the metal you are using as your electrode. So pick a solution of a soluble salt of zinc, or a solution of a soluble salt of copper. That means I can use zinc sulfate solution, I can use zinc chloride solution, I can use zinc nitrate solution. Here I can use copper 2 sulfate solution, or copper 2 chloride solution, or copper 2 nitrate solution, but not copper 2 carbonate or zinc carbonate, because they are insoluble salts. So I want you to be able to remember this, and you can be asked to write the equation for the reaction at each electrode or at each half cell. You have to write it. And remember that it may not be zinc and copper. It can be, say, magnesium and zinc. So you must be able to identify the metal which is more reactive is the one which will be our anode or the negative electrode. And the one which is lower in the reactivity series becomes our positive electrode or the cathode. And you should not forget. So where the reaction starts taking place here is at the metal which is higher in the reactivity series. It is the one which starts losing electrons first. The atoms of such a metal loses electrons to form the cation of that metal in the aqueous state. Meanwhile, at the other electrode, which is made up of the metal which is lower in the reactivity series, it is going to be the cation of that particular metal which is in the electrolyte, which will gain electrons to form that metal. And then you need to combine the equations for the reactions in the two different half cells together, with the reactants being on the reactant side together for the two half cell reactions, and the products also together, so that you form the equation for the overall cell reaction. And make sure that you cancel the electrons which are spectators on the two sides of the equation, same number, and they are both electrons. You just cancel them. What you remain with becomes your equation for the overall cell reaction. And then coming to the cell convention, you have to show what has taken place first, that is where we have the metal which is more reactive. So at the metal which is more reactive, there is the loss of electrons by such a metal to form that very metal ion in solution. And that's what we wrote here. Then you have to use two longer bars, which stands for the porous partition, or the porous pot, or the porous wall. It also signifies or stands for the salt bridge. And in this case, you go to the other side where we have got the metal ion gaining electrons to form that very metal, and you separate them using a shorter bar. Not forgetting, in this case, you don't have to forget the state symbols. I believe that we have followed this, and after this, we are going to look at some equations to this effect that will make us try to see how they set questions on this. We are going to look at some questions to see how questions are set on what we call electrochemical cells, the Daniell cell in particular, or the other original electrochemical cell. So, Tech Talks Education, thank you for watching.